Okay, so hopefully you took the time to draw the diagrams that I assigned you in the previous lesson. Hopefully you took the opportunity to give this exercise some thought. I'll explain how I would go about it, how if you and I were sitting in a room, I would draw it on a whiteboard or on a napkin. And I'm using these terms, these non-permanent forms on purpose because I don't want to give you the impression or anybody the impression that these are the design documents and they're encased in stone. Absolutely not. I just want to use these as a way to refine my own thinking, to communicate my ideas to you and to the other people that might be helping collaborate on the design of the solution. And I'm not ready to be married to these design ideas just yet. Just want to work out my thoughts and get them out of my head and into some format. All right, so let me start off by saying that you may have thought that I was contradicting myself in the previous lesson when I was asking you on the one hand to put off technology decisions as long as possible, but on the other hand to go ahead and draw a diagram that includes technology decisions. Well, there's an expression in the Bible that says with regard to giving that you should not let your left hand know what your right hand is doing. There's a sense in which that's true with how I would regard approaching architecture. On the one hand, I constantly say I'm not ready to make implementation decisions yet, which is true because I don't want to unduly impact my design decisions in the domain layer just yet. However, there's another sense in which I want to give some thought to how this application will ultimately be deployed because it will influence my design decisions a little bit, right? So when I say I don't want to unduly impact my domain decisions, the design and the domain. This is really an exercise of not thinking about technology and deployment, and rather to think about the domain layer in isolation. That's all. As technology people, it's impossible to not at least think a little bit about how it will ultimately be deployed. That's just part of examining a problem from all angles. But what we want to avoid is that those technology decisions drive the entire development process, right? All right, so with that in mind, let's see what you and I both came up with. I'll show you what I came up with. As you can see the diagram on screen, the first assignment was to create a high-level architectural diagram for a web deployment scenario. Map the layers in our application to a physical architecture, or in other words, how we'll distribute the different layers onto physically different systems. Just use big boxes, a big outer box to indicate a physical tier, and by that I mean a machine or a farm of machines, then draw boxes inside of that represent the various conceptual layers of our architecture. For the most part, I'm talking about the layers that we learned about in the Application Architecture Fundamental series. Okay, so as you can see, when I began to diagram the web deployment scenario, I put many of the layers in the same physical tier. The obvious main exception is the persistence, which will live on its own physical tier. So, for example, a clustered SQL Server farm dedicated to supporting this project, complete with rollover redundancy and so on. The physical tier that contains all the layers. Notice I have them all deployed to the same box or the same server farm. Is I guess what I'm hinting at by this diagram. I suppose I could separate some of these out in their own physical tiers, but I don't see the point in it. We don't anticipate any processor-intensive operations like image processing or the like. And I certainly don't want to distribute my layers and add all the network latency. Remember Martin Fowler, who said the first rule of distributed systems is don't distribute your objects, right? So it's better that these layers live on the same physical tier until I have a reason to separate them out, and I just don't have that reason yet. But you might also notice the little audit proxy box inside of the physical tier, and it points out to another physical tier. The proxy is just a code word for go-between. This allows us to replace implementations of the auditing functionality in the future. So we're just talking about a class with a couple of methods that will allow us to call it, and then it is a facade. It wraps up the calls that are ultimately going to Windows Azure. And so obviously, as you can see on the diagram, I'm leaning towards Azure for this auditing solution, and I've just kind of codified that in this diagram. Not ready to commit just yet, but regardless of what technology it is that's going to handle the auditing, I don't want to keep that on the same server because we already talked about the fact that we just want to fire and forget. We want to send it over the wall. We want to just send that message off and not have to ever worry about it again. We don't want it to block the execution of our main application on our physical tier. Okay, so then the second assignment was to create a second high-level architectural diagram for a native device scenario. This will look a lot like the first diagram, but here's a hint. The presentation layer will look different, and at the very least you'll want to add another layer to enable many native devices, phones, tablets, Windows Store apps, and so on. So the only thing that I really added here was a web services layer. Also, the topmost box represents the presentation layer, a native client app in this case. And so that will be obviously many different physical tiers or physical boxes just represented by that one box. I'm not going to draw 10,000 boxes, right? It just, we understand conceptually that that is representative of all the devices that ultimately will be hitting a single web services layer inside of our environment. So the web services layer and its corresponding proxy on the client have the shared responsibilities of serialization and deserialization of the data transfer objects that will be sent back and forth between the presentation layer and the application facade. The third assignment was moving on to the domain layer. What major classes would you envision being a part of our solution? Can you draw a simple UML class diagram showing the classes, some of the properties you'll create, and their relationships? And so what I began to do was to pour over the lesson text from the previous lesson and what we knew about Acme so far. And I start looking for the major nouns: customer, contract, order item, part, location. And location is just kind of a fabrication, something I came up with. It might factor out into warehouse versus customer factory. I'm not really sure about that particular one yet. I'll cross that bridge later once we work into that user story. But as you can see, I start decomposing the user story and all the information we gained as a result of writing that user story and starting to ask questions related to that user story. And I start picking out the major nouns from the user story itself, as well as all the additional clarification that we gained from talking with the client liaison, right? So these nouns become candidate classes. The more I think about each of these nouns, the more I come to a better understanding of whether they are a class unto themselves or just a property of an existing class. So is the contract just a property of a customer, or does it need to be its own class entirely? I would say it probably needs to be broken out into its own class. How about the contract ID? Is that a class by itself, or is it just a property of the contract class? Well, in that case, that just seems like an attribute of a major thing called a contract, okay? How about order item? Is that a property of the order class, or does it deserve its own class with its own property? So those are the kinds of questions I begin to ask myself as I go and kind of order these things out. And, for example, when we talked about contract ID just a second ago, it feels like an attribute of the contract. A contract feels like a class unto itself because I can imagine it has all sorts of additional attributes that we'll need to know about, like the expiration date. And contract seems like it should be related to a customer, not part of the customer class itself. In fact, the more I thought about it, one customer might have many contracts throughout the lifetime of their relationship to the Acme organization. So in a way, we can use the contract ID as a way to identify a specific customer. So I'm thinking we're going to have a customer class, and we'll have a collection of related contracts related by the customer ID that each contract has as an attribute, all right? Or at least that's how it might be represented in a relational database. There would just be a relation back to a specific customer in the contract class. The order item feels like an entity unto itself. An order item is like a line item in an order. Each line item will reference a part at a specific location. And then we're also going to need some way of ascertaining the price of the part. I'm going to assume that the part will cost the same no matter which location is selling it to us. However, I also assume that the part's price may change over time. I could be wrong, and I want to validate that with a subject matter expert, the client liaison at Acme in this case. So order item should include the part price at a particular moment in time. The line item will have its own line total as well, the quantity times the price. An order will have or own a collection then of line items or order items. And when you add up all the line totals, this will create the subtotal for the entire order. All right, so that's the thought process that I go through as I start adding attributes to all the major nouns that I've made candidate classes. So does that make sense? Did you come up with the same sorts of design decisions? Did you put that kind of thought process at work when you were trying to design the classes and think about the attributes that each of them would have? Again, I'm not calling this a design document. This is just a way for me to work out in my own mind the relationship between objects and what the properties are, and kind of foreseeing and maybe even triggering in my own mind questions that I can go back to Acme's subject matter experts, the client liaison, the stakeholders, whatever the case might be, and ask them for more information, okay? But for me, this is kind of an obvious organization of the classes and their properties. It might be because I've done this so many times that I don't even have to think about it anymore. When I took my first relational database class, the organization of data just made sense to me, and so I felt like I was pretty good at relational database theory and COD and all that kind of stuff. And then there are some equivalents into the object-oriented world. You have to change your perspective just a little bit on a few things, but for the most part, you see relationships between things in the real world, and you think, well, how are they related conceptually when I break them down with the intent to create classes out of them in my software? So that's always the mental model that I build in my mind. And so it's difficult for me sometimes to express the micro steps that are required to do this sort of analysis. And frankly, while some have suggested a series of steps that you can take to decompose a problem and come up with the right assignment of classes, properties, relationships, and so on, I generally just sit and think about it for a little while. Is this an object? Is this an attribute of an object? And I'm not even sure there's litmus tests. I mean, some people have suggested those, but it just kind of makes sense. Like, looking for something on my desk here. Screwdriver, all right. This seems like it's an object of itself. It has properties of, the color red, and it has a type of handle, rubber. As opposed to plastic handle. And another attribute would be a Phillips versus a regular head on the screwdriver, okay? And I don't even know why I have a screwdriver on my desk right now. That wasn't planned. But at any rate, you start thinking, well, then is this screwdriver part of another object, a larger object called maybe a tool chest? Well, I don't think so. It feels autonomous. It feels like it should be something by itself. So that's the kind of analysis that goes on in my mind. Does it feel right to put this here or to put this here? Is it part of something else, or is it its own thing entirely? All right. And most of the time I get it right, but occasionally once new information comes in, I might find that I was off the mark a bit. That's okay. I try to stay flexible in this process. These are simply candidates, not my final decisions. It's like a foggy morning. I begin to make out big shapes through the fog. And then as I get closer to my car out in the driveway, I focus more. I can make out more of the details. As I become more familiar with a concept that I've identified as a candidate class, I can see more detail. And it might change my perception of what it is. And so I'm doing that here too. I suspect as I get closer and closer to these candidates over the next several lessons, my perception will change slightly, but overall I feel pretty good about what I've got so far. All right, one thing that might need some clarification on is IDs in the system, and that's always kind of a sticking point. And every organization has a different way that they want to do identifiers, IDs. I'll assume that they're not going to change appreciably. But for now, based on what I know about the client's existing system, I'm going to assume that the IDs for each entity, so the contract, the customer, the order, the parts, they're either GUIDs, globally unique identifiers that are generated by the computer system, or some fabricated number that has some meaning that's encoded into it. So for example, here's a contract ID that we would see in the existing system. You can see that it's a combination of perhaps a company name, a geographical region, a classification, in this case MIL for military, perhaps a date timestamp of when the customer's record was originally created, and maybe some other factors as well. This might be a relic from a legacy mainframe system because those crafty developers were always trying to slip data into identifiers in some cryptic way because they only had so many bits to work with or whatever the case might be. Well, I'll get clarification on that a little bit later. For testing, I'm simply going to use strings in the system whenever I'm building the unit tests. And when I need to generate an ID for some purpose, I'll create a GUID and convert it into a string. This will make it unique, and I need to be able to be sure to isolate the ID generation code into its own replaceable module so I can revisit that in the future once I know more about the qualities and the makeup of each of these IDs. Alright, so we've made some preliminary design decisions or observations at this point, both at a high and a lower level, but now where should I start? Where do I move on from here? I'm looking at essentially a blank page in Visual Studio. I don't have it up right now, but at some point I've got to get started. I know I'm going to have a few classes, I know a few properties that I'll need for each class, but that's about it. Well, we're going to take a test-driven design approach. That means I'm going to let the unit tests drive the process of designing the classes, methods, properties, and their interactions. So my first order of business is to create an order for an existing customer. That was pretty much what we decided on for the first user story. So I'm going to need to get a customer object, and I'm going to need to create an order for that customer. At first, the order will be empty. It'll have no order items associated with it. It'll have a status of property set to new. So the most basic thing that I could do to kick this off is to think in these terms and really just break this down a little bit. Given a valid contract ID, I want to receive back a contract from the system. I'm going to want to determine whether that contract's expiration date is valid. If not, I need to notify the end user. Orders are related to customers, so grab the customer for the current contract out of the persistence layer. And then I want to create a new order for that customer. The order should be initialized to a valid state, so the order's status should be set to new. Okay. And then the user is going to type in a part ID, and so we want to show any matches, including quantity on hand. The user will select one part location combination in the system, and then they'll type in a quantity, and that will create an order item, and it will be associated to the order. The order's contents will then be displayed somehow on screen and will allow the user to search for another part, kind of repeating that process of adding additional parts to the order. The user can then choose somehow to finish the ordering process, and this will set the order's status to open. Now, honestly, I usually don't spell out what I'm going to do in quite that much detail, at least in this sort of forum. I may have an internal dialogue as I read the user stories and my existing code, and I think to myself, what needs to happen next? But this is how I would decompose the problem. I'd identify the classes I'll need, I'll delegate responsibilities to the classes, and so on. If not out loud, at least to myself. And so, given this list of steps in the process to enable the user story, my next task is to create unit tests that force me to write production code to make those scenarios work. So let's take that very first step that I broke out. Given a valid contract ID, retrieve a contract. And I could further break that down into a unit test or a series of unit tests. So, for example, I want to make sure that I can create a new instance of a contract class. That's a unit test. I would call a getById method passing in a contract ID that the user types in, and I would expect that the contract's properties, so its expiration date, to be populated in the contract. So I want to make sure in another unit test that I'm actually getting back an expiration date for a contract ID that I'm passing in. I'd call a validate method possibly to perform a check on the expiration date to determine if the contract is in good standing or not. So that's 2 unit tests. I pass in a contract to a validate method, and it's going to either tell me whether the contract is valid or invalid based on expiration date. And so in that scenario, I would expect if it's not valid, I would probably want to raise an exception, a custom exception, to the validate method, and so I'd want to test that. If the contract isn't in the database, perhaps the user typed it incorrectly, I want to raise a different type of exception. Whoever called the find by ID method, I would want to raise an exception there. So right there I've outlined 6 or 7 different unit tests, things that I want to test, both the scenario where it should have worked and test the scenario where it didn't work, that it's raising the correct exception in the system. But these unit tests that I'm beginning to identify in my mind, they'll force me to create classes and methods, and then I anticipate that it will also force me to create custom exceptions. But the payoff is that from this point on, I'll have the confidence that finding a contract works, and if it ever does break, I'll have a pretty good idea of what broke it. But as I begin to further decompose the user story into unit tests, this is when things start to get messy, especially at first because everything is in this gelatinous state trying to congeal. We're going to follow the mantra of red, green, refactor, and we'll shape and mold the code into a more congealed state that we can rely on. And so I'll be introducing new unit tests and new production code in the domain layer, and we'll just keep that cycle going. I'll be introducing new layers and interfaces and fakes, and each time adding a little bit more uncertainty, then shaping and working with it until it all looks good again. And while I do this, all those topics that we talked about in the Application Architecture Fundamentals series should be coming back to you over the next 10 lessons or so. So the next step is to get the solution set up, to create the domain layer project and the unit test for the domain layer. And so we're going to do that in the next lesson. We'll get started there. We'll see you then. Thank you.